All right, 3.4 is talking about the greatest common factor. Okay? Now, what the greatest common factor is this. For every single number, for example, 8, we've already talked about this. Every single number has factors. Okay? The factors of 8 would be what? Somebody raise your hand and tell me. Xander.
1, 2, and 4.
And
8.
There you go. 1, 2, 4, and 8. Okay? Those are the factors of 8. Okay? Now, if we list the factors of, let's say, 12. What are the factors of 12, Jesse? 1, 2, 3, 4, 6, and 12. Okay? Now, if we look at those two numbers and their factors, okay, the very first one that they have in common is the 1. Okay? Every single number is going to have 1 as a factor. Okay? Every single number. So if they have nothing else in common, they will always have 1. Okay? Now, for this particular problem, the 2 is also common, and that's pretty much it. Ah, see, good. You're not napping on me. Okay? The 4 is common. Okay, so the greatest common factor, the greatest common factor, also known as the GCF. Okay, so the GCF of 8 and 12 would equal 4. So, the first way to find the greatest common factor is by listing all the factors for each number. Okay, that's the first way. Now, that's fairly simplistic when you've got small numbers. Okay? The problem you have is this. I'll go back to first hour this morning. First hour, we did the greatest common factor. There's two of our numbers, 144 and 264. Okay? So you can imagine listing all the factors for those two numbers. Then we had 36 and 168. Okay? So you can see that obviously we're not always going to have simple numbers like 8 and 12. Okay? So we need to know another way to do it without having to list all of the factors. Okay? For example, and they're going to give you some larger ones as well. Let's say I had this. Let's say I had 49 and 56. Okay? The second way to find the greatest common factor between numbers is second way to find the GCF is to prime factor the numbers. Okay? So, once again, I don't care if you use prime factorization method, number factor tree, or inverted division. Any of those two, I don't care. In class today with the 7th grade this morning, some of them used both ways in the problem. Okay, they did one number in factor tree, they did one number in inverted division, because one of the numbers was real easy. For example, one of the numbers was 144. Okay, well, most people know that two factors of 144 would be 12 times 12. Okay, and so they would do that with the factor tree, and the other one was like 198. Well, they don't readily know two factors of 198, so they use the inverted division on it. That's fine. Okay, a lot of them just use inverted division. I think only one of them this morning used factor tree exclusively. Okay, so like I said, I don't care which one you use. In class, I'm going to do inverted division. But if you use the factor tree, then when I'm doing inverted division, simply do yours with the factor tree. Okay, so 49, this one's fairly simplistic. We know it's 7 times 7. Okay, so 7 times 7. Okay, 56, well, that's 2, 28, 2, 14, 2, 7. So this one is 2 times 2 times 2 times 7. Now, what you do next, first you must prime factor them. Okay, so step 1, prime factor. Step 2, find the common prime factors. Okay, so as we look at this, there's a 7 in common. Is there any more 7s over here? No. There's no 2s that are common. So the only thing that is common is the 7. So my GCF is equal to 7. Okay, now, your answers are not always going to be prime numbers. Okay, let me show you an example of one. 84 and 120. Okay, prime factor 84, you get 2, 42, 2, 21, 3, 7. Okay, we prime factor 120, 2, 60, 2, 30, 2, 15, 3, 5. Now, realistically, I don't even have to list it out. There's one that's common, there's one that's common, and there's one that's common. So, to find the GCF, I take these three numbers and multiply them together. 2 times 2 is 4 times 3, which is 12. So the GCF is equal to 12 from those two numbers. You will notice that I didn't go 2 times 2 times 2 times 2 times 3 times 3. I didn't do that. That is wrong. You don't multiply all of the prime numbers that are common together. Okay? You simply multiply one of the pairs in each one together. Okay? So this right here, that's a 2. This right here, that's another 2. Okay? And then the 3. All right? I will do another one to help you out. Yes, Celine. We take the number with the least amount of factors. No, you find the common ones. Because, I mean, what you said, well, that one has a 7 in it. That's the least one, but that's not in the other one. So you can't use that 7. You can only use it. Now, if you still need to do this, okay, if you need to take and list this out, like that, and then underneath it, put 2 times 2 times 2 times 3 times 5. Go ahead and do that. Whoa. Thank you very much. Thank you for playing our game.